Lesson 2.2, Video 2. So when we look at a system of equations, our first decision must be, is it ready for substitution? And again, we are focusing on a method of solving a system of equations by substitution, which states in our process that at least one of the equations must be solved for y for you to begin. Both can also be solved for a variable, but one is enough. Now I say solve for y, but that could be any variable. You could have an equation solved for any variable as long as it's solved for one of them. Now notice that we have an equation that's solved for y. It's telling us that y is equal to negative 4x plus 20. We are going to take that expression and substitute it in for the y in the second expression, which would give us 4x minus 2, and the y is now going to be replaced with negative 4x plus 20. So we replace the y in the second equation with the expression from the first. Notice now we went from an equation that had two different variables to an equation with two of the same variables, in which we can now combine like terms and solve for x. So our process would be to say distribute the negative 2, which would give us 4x plus 8x minus 40 equals 20. And we can solve this expression for x, and we get 12x minus 40 equals 20. We would add 40, and we would get 12x equals 60. Again, this is a 2. Divide by 12, and x equals 5. Now remember that we are looking for a coordinate, and we've just found the x value of that coordinate. So we'll take that answer, and we have a choice. We can plug it into either equation to find out y. Now here's where it becomes a choice of efficiency. Which equation is going to be easier to work with? Which I would probably say is this one. So I would say y equals negative 4, and you know what x is now. It is 5 plus 20. So we have y equals negative 20 plus 20, so y is equal to 0. That is the y value of that coordinate, and you have now found the intersection point of the two lines. So if I were to graph it, it'd be at this coordinate right there. So let's try another one. Here we have a system of equations, where they're both solved for a variable. Now some would say that this is not ready because they think only one needs to be solved for a variable, but this one is actually very, very ready. But we have a choice where we didn't have a choice before. I could go either direction, but I'm just going to choose this method right here, this step. I'm going to substitute the first expression into the second. And again, I could go the other direction, but this is good enough. So I will get negative 3x plus 5 equals x minus 7. So I basically took this and replaced it with that. So again, solving for x, I will subtract x from both sides, and it's your preference how you want to do that, what direction you want to take. Now I have negative 4x plus 5 equals a negative 7. I will subtract 5, and we have negative 4x equals a negative 12. Divide both sides by negative 4, and we have x equals 3. Now again, we're looking for an intersection point, and we just found x. So I'm going to take this, and I have a choice of plugging it into either equation, whichever looks easier to use. In this particular case, I think this one looks pretty easy to use right here. So I'm going to say y equals 3 minus 7, so y equals negative 4. And that is the coordinate. And again, if we were to graph the lines, they would intersect at positive 3, negative 4. And this ends Lesson 2.2, Video 2.